This is Jeopardy!
A classic children's book by Crockett Johnson, Harold and the Blank Johnson.
What is purple?
This is Watson. Watson is the most advanced supercomputer in the world. He can diagnose cancer, fight cybercrime, and of course, play Jeopardy. But what if I told you there's a machine out there that's even smarter than Watson? That's right, the human brain. The human brain is still significantly better at a wide variety of tasks that use skills like creativity, common sense, or language understanding. So, what makes the human brain so powerful? Well, we don't really know yet, but we do know that the answer lies somewhere within the way that the brain functions. I introduce to you the Human Connectome Project. So, what is a connectome? A connectome is a map of all of the nerve cells and synapses within the brain. Our brains, just like the rest of our bodies, are made up of millions and millions of individual cells. These nerve cells, or neurons, communicate with one another by sending chemical and electrical messages through areas known as synapses. Similar to how a map is not just a bunch of cities and locations, it's also the roads connecting them, a connectome is not just where each neuron is in the brain, it's also how they're connected. Hence the name connectome. There are two types of connections within the brain. Structural connections are the physical connections between cells. Functional connections explain how different regions of the brain talk with one another as a whole. Similar to how maps that show the whole country or maps that show just an individual state or county yield different conclusions, looking at the brain at different scales or different layers can yield different conclusions as to how it communicates with itself. To understand these different layers, scientists are aiming to create connectomes with different scales. First is the macro scale. This is where scientists currently are, capturing the brain in chunks of 1 millimeter cubes to capture large brain systems and grouping those systems into distinct modules. Second is the mesoscale. This consists of approximately 100 by 100 micrometers of space at a time to identify functionally distinct neuronal populations. And lastly is the microscale. This is the neuron by neuron map where each individual neuron is accounted for. Scientists use something known as the block method to create these connectomes. They take a 1 cubic millimeter block of brain tissue and slice it with a diamond knife. Then they capture each of these slices onto high-definition cameras. Each photo is 250,000 by 250,000 pixels. Lastly, scientists stack up all of those 2D images to create a 3D model of the brain. The Human Connectome Project is far from complete. In fact, it took scientists 5 years to map just 3 billionth of a mouse brain. However, we have lots to look forward to in the field of neural engineering.